morning, my YouTube viewers. It is Crystal here. I'm just here because I wanted to make a video for you, a code review of the latest Kaggle community competition that I have entered. I try to enter the community competitions every month just to keep my machine learning skills up to date. Although the community competitions aren't that difficult to encounter if you only do it once a month, it's really easy to forget things because I'm doing other things at the moment than just machine learning. But what this competition is you have to predict on the price of a backpack. And so when you predict on the price of the backpack, I've used the ElasticNet model from sklearn, and the reason why I've done that is because I tried linear regression, and I was just wondering if ElasticNet would work better than linear regression. So I used ElasticNet instead of linear regression, but both of those models are very similar. So I even got 2 comments on my Jupyter Notebook, as you can see. And the 2 comments on my Jupyter Notebook, he asked me why I used ElasticNet. I used it because I just wanted to try something different and see if ElasticNet would work better than linear regression. And I think that they both worked about similar. When I saved my data, when I saved my predictions and ran them and submitted them to Kaggle, I got 39%, which you think, oh, 39%, that's really high. But the highest score was 38%. So even though I had scored 39, I still scored only 1 point less than the highest score. So that was good. We go into our problem statement. Problem statement is that we predict on the price of a backpack. And then what we do is I have used Kaggle's Jupyter Notebook to write my program, and then I saved it in my Kaggle account. And one thing that I will do is I will save a copy of this Jupyter Notebook on the video. So if you want to look at my Jupyter Notebook, you can. The first thing that we do after we define our problem statement is we import our libraries. So we're going to import NumPy to carry out numerical computations and to create NumPy arrays. We're going to import pandas to create data frames and process the data. We're going to import OS, which is going to go into the operating system and retrieve the files that we're going to be using. We're going to import sklearn, which gives us our machine learning functionality. We're going to import PyLab, which is a library that's going to help us look at a goodness of fit model. And then we're going to import SciPy to create a QQ plot. We're going to import Matplotlib to visualize the data, and Seaborn to also visualize the data. And then so we're going to retrieve the files using OS. And then when we retrieve the files using OS, you're going to get train, test, and submission. And you're also going to get a training extra, which I didn't open because apparently it's got lots and lots of data in it. And so I decided not to use it because my computer doesn't have a lot of power. We're going to convert the CSV files to data frames with pandas. And then so our data frames are going to be train, test, and submission. So we're going to look at the train file. The train file has 11 columns of data. with the final column of data being the price, which is the target. And then we check info, want to see what each column of data is comprised of. So you can see we've got integers, floats, and objects. We're going to check for null values. You can see that we've got quite a few null values. So in order to deal with these null values, we're going to drop all of the null values from the training data set. And when we drop all the null values from the training data set, we have less rows of data. Before we had, I think, 300,000 rows of data, and I think now we've only got 246, almost 247,000 rows of data. We've got an extra row, I don't know how that happened, but it's in there. I'm not changing it. And then we check our test file. Our test file is similar to the train file, except for the fact that it doesn't have a price column, and that's what we're going to be predicting on. We check for null values in our test file, and you can see we have quite a few null values in the test file. Check submission. This is what Kaggle wants to see when we submit our data. It wants to have an ID column and a price column. We're going to drop the ID column because it's not needed when using pandas. So that's just one column, less column that the machine learning algorithm has to deal with. Now we're going to analyze the train column, the train data frame. And so basically what we're going to do is for each column that is an object column, we're going to print the unique value. So we've got the unique values down for each column. And fortunately, I don't think that any column has more than 6 categories, which is good. And so since it doesn't have more than 6 categories, then what I've done is I've created histograms for all of these categories. So this is the brand column. So you can see the brand, that they're all relatively close. And I created a histogram using Matplotlib. This is the material column. You can see that the material columns are quite close together as well. You can see the size column. The size columns are quite close together. You can see the laptop compartment column. You can see that they're quite close together. You can see the waterproof column. You can see they're, close together. See the style column. The styles are quite close together. You can see the color column. You can see that the most popular color is pink and the least popular color is black. Now we're going to analyze our target, and we're going to use sklearn to analyze the target and make a kernel density estimate. So you can see that all of the prices are pretty much, you've got a value count of all of the prices pretty much even, except for after 140 it shoots up. So you do have a few bags that are quite highly priced. So now we're going to impute the null values in the test set. So for the column in test, if the D type of the column is an object, then you're going to replace it with not listed. And if the D type in the column is an int or a float, then you're going to fill it with a -1. And so we don't have any more null values after we have imputed all of the null values. So now what we're going to do is we're going to use sklearn's ordinal encoder to encode all of the categorical columns. So if the column is an object column, then it's going to be ordinal encoded. So now what we want to do is we find out what kind of columns are in the train file after we have ordinally encoded them, and you find out that they're all floats, which is what you want to see. And I wanted to point out that we ordinal encode both the train and the test data frames. So we check the test data frame, and you can see all of those columns are floats as well. So now we're going to define our dependent and our independent variables. Your dependent variable is price in the train data frame, and we're going to pop that out. And so when you pop that out, it's no longer in train. And then your independent variable is x, which is the remainder of your train data frame. And your x test is another independent variable, and that's your test data frame. So we're going to split the training and validating sets up. So we're going to split it into training and validating sets. And then we're going to check the shape of the new data sets that we have created. Now we're going to define our model, and I decided in this piece of code to use the ElasticNet. And then when we use the ElasticNet, it's similar to logistic regression. So I just thought, well, I'd try this out, see if it performs better than logistic regression. And I've got an accuracy of 0, basically. And then I check my predict on the validation set. And so you can see that when we predict on the validation set, all of the prices are in the neighborhood of 81 or 82. We calculate our RMSC, and then in the Jupyter Notebook for Kaggle, the RMSC function in sklearn has not been added to Kaggle, and that's because Kaggle has not updated the most current version of sklearn. So what I have to do is I have to calculate the mean squared error and then get the square root of that to convert it to the root mean squared error. So you can see that we have a noise level of 38 RMSC. Check the data frame. You can see when we check the data frame, all of the values, prices are around 80 to 82. But we create a QQ plot, and when we create a QQ plot, it doesn't look too bad. This line that is being made is actually along the prediction line of the QQ plot. But what we do is when we plot the actual values against the predicted values, that's where you can see that there is a problem where all of the values are between 80 and 82 really. So now we predict on our test set, and all of the values again are 81, 82, and then we prepare our submission and convert it to a CSV file, and you can see all of the files are between 81 and 82. And I've got a 39 RMSC, which is 1 degree, 1 point less than the highest RMSC in Kaggle. But one thing that I would like to say is I thought that I would give extra trees a try, give that model a try. And whenever I tried extra trees, 1, it took a long time for it to train it. And 2, whenever I did the probability plot, the QQ plot, the predictions were almost all the way across the red regression line. But whenever I checked, the RMSC was like 43. And then whenever I put the predictions across the regression line in Matplotlib, it was just all over the place. But I did get a larger variety of prices than I got when I was using the ElasticNet. So what that says to me is, even though I got a low RMSE, which that's what they want you to have the lowest RMSE as possible. That doesn't necessarily mean that you got the most accurate model. It's not the most accurate model, and the reason why it's not the most accurate model is because of this. Because in order for the model to be perfect, what you would have is you would have all of the predictions lined up closely around the regression line, which we don't have. So obviously that's something that needs to be worked on. I don't know, I might try a different model, or I might try some feature engineering, find out if I can get some feature engineering and see if that will improve my score. You never know, a little feature engineering might do the trick. So I'm going to go ahead and conclude this video. I'd like to thank you very much for watching my video. If you like my video, please like and subscribe. I also want to let you know that I have a second YouTube channel where I just talk about my life, and it's called Palestine. So if you would like to know about me personally, you can always tune into that channel as well. So thank you so much again for watching my video. I will be making you another video very soon.